So to view a specific plot, I'm going to click the tile for the plot and select the Shapley values for original features plot in the DAI Models tab. This is a chart available for all binary classification, multi-class classification, and regression experiments, and it shows the features in descending order of importance for our best model. And this plot answers the question, which are the original features from our dataset which contribute the most to predict whether the credit score is bad or good. What I like about the Shapley graph is that you can search a particular application based on the row ID. This is a great functionality to have because I can search for each single row in my dataset and its particular characteristics. Let's take a moment to evaluate the output that I got. But just before, for learning purposes, on another MLI report that I ran on the same dataset but with different settings, I have received the following results. Do you see anything peculiar here? If your answer was yes, then you are definitely on the right track. We can see that the name, the type of loan, occupation, age are the features selected by our best model as being the most important in predicting the target outcome. The name feature does not make any logical sense here, as the decision of whether a credit score is good or bad should not be influenced by the name of the applicant. Maybe there is something else going on here? Let's go back to the details section of our dataset. Are there applicants who applied multiple times for a loan? Might that indicate to the algorithm a behavior that is worth considering? If I go on the Datasets tab and select the credit score.csv dataset, and then click Details, I am able to see the descriptive statistics that we learned about at the beginning of the class. And what I observe is that out of the 100K applications, there are only around 10K unique applicant names and exactly 12,500 unique customer IDs. So we learn a couple of things from here. First of all, in our dataset, we have the customer names, which are the same for different IDs, which could be normal. That's why we have IDs in the first place, to differentiate between people of the same characteristics, such as the name or the place of birth. This doesn't mean that they are the same person. Please note that driverless AI takes out the IDs by default when training a model. This is an option that you can also change in the expert settings of the experiment if you want. Secondly, we do indeed have applicants who applied multiple times. If we click on the Dataset Rows button, we have a preview of who some of them are. And there are a couple of them, for example, Ank. This person has the same customer ID, the same name, but different application IDs, 4 in total. Are there any duplicates? You might want to check for this too, and we saw earlier how to account for them in case you want driverless AI to take care of them from the expert settings. Depending on your business case, you might want to drop the feature name from your next experiment. Nevertheless, in the plot from our current MLI report, this redundancy has been taken into account by the driverless AI and the name appears on the second page of the Shapley values for original features plot